Well, hello everyone, and welcome to yet another problem from Geeks for Geeks. It says max sum subarray of size k. The problem goes like: given an array of integers arr and a number k, return the maximum sum of subarrays of size k. Note: a subarray is continuous part of any given array. Within an example, we have provided this array with k2. k2 means the array subarray should have size of 2. So either 100, 200, 200, 300, 300 or 400. So these are three subarrays which we can take out from the array. Now subarray with maximum sum is 700 from 300 and 400. Now this might not be always true that subarrays maximum sum subarray would lie on the last. In next example, we may find that k is 4 and we got 4 with this size, this array, and so on so forth. We have k as 1 as well, which is pretty much easy. Now we have expected time complexities, which is O of n and O of 1. We have to adhere this complexity and we have to write an minimalistic and simpler algorithm for that. So for a naive way or in a brute force approach, how we could have been solving this problem be like: in a brute force way we can solve this problem for I and for j, where I and j like I to j, it would form a subarray, and with that subarray we can have sum and we can keep track of sum, but this would cost us time complexity itself of O of n square. Obviously we don't want that. Now can we optimize this? Yeah, we could optimize this. We can go ahead, we can understand how subarray is being calculated. So for array like this, let's take approach. For array like this and k equals to 4, I'm not sure, yeah, k is 4. So k is 4, how the subarray would look like. So the flaws within earlier problem was O of n square for two arrays, which was taking subarray in this fashion. Then it was taking subarray from 4 to 23. I'll take in this way. Next it was taking subarray from 2 to 3. Now there is an idea behind this, that hey, when you notice that we are eliminating the last character every time and we are adding up a new character, in this case 23. So what does it mean? What am I gaining from this? So the point which I am trying to make over here is, let the sum for this is S1, then here the sum would be S1 minus X, where we are leaving X, and a new number we would be accommodating, which is N. So leaving X and accommodating 1, that means plus N. That is the thing which we are trying to do. And prior to that, we have to this happens only and only when we have sum for array of size k, and once we have that, we can go ahead and roll the sum over and over. What does rolling the sum means? Remove the last, add the new, and that's what it is. Simple and easy. So nothing much fancy, and while doing this we will keep track of maximum sum found so far. Also don't lose track of current sum, because current sum is the thing which we are required to remove from and to add new element to. So in overall I would have two variables, maximum sum, which initially should be 0, a, int current sum, which is also 0, and we would be looking later upon what to return, but for now we would iterate within an array. Obviously the array would start from I is equal to 0, I is less than a dot length I plus plus. Now initially current sum is empty, the size is 0, that means no element is considered. So we need to consider at least k elements, right? So if my size I is less than k, then that means I need to first fill the first k elements. This is the point where I am actually creating this line, this size. So when and only when I have this size, that is S1, I can go to S2, which would be nothing but this. So because I just want, my sole objective over here is to just generate a current sum. I would figure it out later upon how to track maximum, but let me finish on current. So I would take a of I and continue to the next one, because I wanted to fill the k size first. I wanted to fill the k size. I wanted to consider at least k elements. Now once my control is over here, I am sure to have k elements. Now I'm sure to have k elements. Next thing is roll the sum over and over. That means remove the last and add the new. So I'll copy these two lines, remove the last, add the new. How do I remove the last? So current sum minus is equal to a of I minus k. So this is the last thing which I can get, because if my item is starting, my index is starting from 0, 1, 2 and 3, and I am currently at 4. So at 4 I'm sure that at 4 I'm sure that the size is complete. And now remove last, and last would be this element which is 0. And how could I get 0 is I minus k, and what is I? I is at 4. So yeah, I minus k, and I wanted to add new. So current sum plus is equal to a of I. I is the newest element, but wait a second, I wanted to track the maximum sum as well. So maximum sum is equal to mat.max of maximum sum comma current sum. Also post this operation we would be having some maximum sum which would be untracked once the for loop is ended. So I don't want to miss upon that sum as well. So I'll return mat.max maximum sum comma current sum. That's it. Let's compile this one to see any compiler errors. Do we have? And yes, there is no cum sum, there is current sum. Yeah. So no compiler errors found. Let's try to submit this one for rest of the test cases. So yeah, it has passed rest all the test cases, and cool. This was a problem of prefix sum, sliding window and algorithms. For more such prefix sum and sliding window related concepts, click the video on your right, and I will see you in the next one.